Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is confidence level. In this activity, we will be using an applet to learn what it means to say we are 95% confident that our confidence interval captures the true proportion. We're going to be using the applet and make sure that we set the population proportion to 0.5 and the confidence level to 95% and the sample size to 75. So let's go to the applet. I'm sure you can see the link in there. We have to make sure that the population proportion is 0.5, our confidence level is 95, and our sample size is 75. This green vertical line that you see here, this is the true proportion, right? What we would like to do here is when we have our confidence interval, will we catch or will we touch this green vertical line? Because if we do, then that means we captured the true proportion. If we don't catch the green line, that means we are not capturing the true proportion. Maybe we're all the way higher than 0.50 or we are all the way lower than it. Okay, moving on. We have here, click a sample to choose an SRS and display the resulting confidence interval. The question here is, did the first confidence interval capture the true proportion? So I'm going to go back to the link and then I will click sample, this green sample one time. And it looks like I have a 0.547 plus and minus 0.11. The dot in the middle, that is your point estimate. Okay, that is your point estimate. And then, of course, the 0.11 is what we call our margin of error. And this time, the green line passes through the segment. That means we captured the true proportion in our first confidence interval. So here it says, yes, did the first confidence interval capture the true proportion? Our answer there is a yes. Repeat this 10 times and sketch what you see to the right and how many of the intervals capture the true proportion. So let's do that 9 times. Of course, you're going to sketch that. Let's sketch the first one. 0.54 from to 60. Okay. I forgot. Sorry. Past 0.50, past 0.60. So right around this area. Okay? And then I am going to do it 10 times, so 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It looks like all my segment is catching the green line, right? If you can see the fifth 1, 2, 3, 4, 5, the fifth one, the fifth segment, it looks like it's almost not catching our true proportion, yeah? But it still did on the upper side of it. Okay, so going back to the question, repeat this 10 times and sketch what you see to the right. How many of the intervals? Of course, you need to make sure that you sketch your result. In here, my result might not be the same as your result. Okay, and this is a simulation, so do not be like, oh my goodness, when I click mine, your interval is lower than I have, and that is okay. Okay, repeat this 10 times. In my case, 10 out of 10 capture the true proportion. In yours, maybe 9 will capture the true proportion, maybe 8 will capture the true proportion, and then the 2 will not. Okay, you will know when it doesn't capture the true proportion because it will turn into red. Okay, number 3, reset and then take a total of 100 confidence interval. How many out of 100 capture the true proportion? Is this surprising? Why? So we have out of 100, how many is going to be captured? So I'm going to go back. I'm going to click reset. Reset is red at the bottom. And then I'm going to click 100 samples. So instead of taking sample 100 times, I'll just use this 25. sample of 25 and I need 100, so I'm going to click it 4 times. So this is 25. Do you see the red? I have 3 red in here. The red means that this interval is not capturing a true proportion. So one more, another one, that's 75. See, I have more red, and then I'm going to click one more. Okay, right now I have 92. Again, you see how you'll see only blocked in here? Because the rest of it, you know how 100 confidence intervals, it doesn't fit in here. So some of the intervals that are red are now hidden, right? Because they all not fit into the screen. And so you will have to look over here, how many hit. Hit means how many captured the true proportion and how many didn't. So we have the percentage of hit is 92%. So in my case, again, yours might be different. In my case, that is 92 out of 100, which is 92%, caught the capture the true proportion. Is this surprising? Why? This is not surprising because this is close to our confidence level. You know how I pick a confidence level of 95%? So I expect that 95% of my intervals will capture the true proportion. Does that make sense? So in here, I did get 92, but sometimes maybe you'll get 95, you'll get 94, but for as long as it's closer or about the same as 95%, then it should not be surprising. Okay? For number 4, what's your confidence interval as you drag the confidence level from 95% to 99%? You don't have to reset. All you have to do is change the confidence level. What happens to the interval when the confidence level is increased? And why does it make sense? Okay, let's go back there. We have to change this to 95. Sorry, right now this is 95. I'm going to change it to 99. Okay, take a look at what's happening. This is 95. This is 99. This is 95. Take a look at what happens to the interval. And this is 99. It looks like when it's 95, it's narrow. But when I click confidence level to 99%, the segment becomes wider. Right? That means the confidence interval becomes wider. Okay? So intervals or confidence intervals get wider and more of them capture the true proportion, which is P equals 0.5. So we need wider intervals in order to be more confident. Okay? So let me put a note over here. When the confidence level go up, the margin of error will also go up because the confidence interval, like the line or the segment, goes wider. Okay, now we're gonna click a reset and then sample 100 times at an 80% confidence interval. What percent of the intervals capture the true proportion? So let's go back there. We're changing the confidence level to 80%. Oh, it looks like I have more red right now, right? So I have 70% so I have 70 out of 100 that is captured. Okay, wait, I have to click reset. And then I click a sample of 25 4 times. Okay, here you go. Now I have 75% out of 100. Again, you might get 76, you might get 70, you might get 80%. We are gonna vary for as long as we did it correctly. We should be almost to the 80%. So I expect that 80% of my interval will capture the true proportion. But right now, 75 did, but that's okay because that is a number that is really close to 80%. So how many percent? So mine is 75 out of 100, which is 75%. Interpret the confidence level. And remember now, our confidence level is at 80%, right? So 80%, I'm going to be using that because again, answers vary. But if I have to interpret what an 80% confidence interval is, I would say 80% of the intervals, let me just note in there, capture the true proportion. If I have to describe that, I would say if we take many samples and calculate a confidence interval for each, we expect about, I said about because sometimes it gets 76, sometimes it's 75, sometimes it's maybe 81, about 80% of them to capture the true proportion, which is in this case, it's 0.5. Okay, there you go. So the red is how you will interpret confidence level. And of course, the confidence level changes. So if that was a 90%, I would say if you take many samples and calculate a confidence interval for each, we expect about 90% of them, 95% of them, 98% of them to capture the true proportion. Okay? Now, we will see what happens when we adjust the sample size. Change the sample size to 20 and sample for one interval. So I think we have to reset and then change it to 250 and sample for one interval. What happens to the interval when the sample size is increased and why? Okay, let's reset everything first, okay? So we have, let's put it back to a confidence level of 95. And then we're going to do a sample of, how much? 20? There. Sample size of 20, and then we'll take one sample. Okay? So right now, this is my sample. This is my confidence interval. If you notice, it's really wide, right? It ranges from just more than 0.30% and then a little bit lower than 80%, right? So let's just say from 35 to 75%. Okay, and that is when I had a sample size of 20. Now, what if I make the sample size 250 according to our instructions? So if I oh, that's a lot. Where's 250? There. If I change the sample size to 250 and I take, remember, my sample earlier from 35% to 75%, right? So if I increase the sample to 250, click sample, oh, take a look. Take a look at how narrow this is, right? Instead of from 35 to 75, now it's ranging around our true proportion 50%. So it gets narrower. Does that make sense? We're getting closer to the true proportion. So our interval or our estimate gets narrower. So that means when n is increased, the margin of error will decrease. Does that make sense? If you have more sample, your estimate is getting narrower. You're getting closer to the true proportion. So this is the interval. When we increase the sample, the interval is much narrower. Sample size goes up. Variability, we know this, right? Variability of the sampling distribution goes down. There you go. Okay, so what did we learn today? We have learned to interpret the confidence level. So to interpret confidence level, we say if we take many samples and calculate a confidence interval for each, too much writing, right? About blank percent, 90%, 80% of them will capture the true proportion, or not really proportion though. Let me take that out. We'll capture the true proportion, we'll capture the true mean. Oh, sorry. We'll capture the true proportion or capture the true mean, depends. Right? Depending on what context we have. Okay? Oop. There you go. So, if we take many samples and calculate the confidence interval for each, about 95, 80, 85 of them will capture the true proportion, or we can say we'll capture the true mean depending on what context we have. Okay? So, margin of error. What happens to the margin of error? If we increase confidence level, margin of error will also increase. Okay? If we increase n, or let me just put sample size. If we increase the sample size, margin of error decreases. Okay? And then, what else? Oh, I don't have a space. Hold on. Let's put these closer. Confidence level up. ME up. Sample size up. ME down. Okay. So we have a margin of error. I don't know if you remember the sampling bias. Margin of error does not account for sampling variability. Okay. Margin of error does account for sampling variability, but does not account for, do you remember this? Non-response. It does not account for non-response bias. It does not account for undercoverage. It does not account for response bias. So non-response bias means that when you call people, we have a list, you call people from the sample, and then when you call them, they don't answer. That's what we call non-response. Undercoverage is if there's a group of people, I hope you remember chapter 4, if there's a group of people are not going to be able to be part of your sample because, let's say, if you are using telephone numbers and some people doesn't have telephones, if you're using household, some people live in an apartment. So those are what we call undercoverage. Response bias, if they lie about their response. Let's say you ask them how many times they went to the movies, and they say, to just look cool, they say, oh, I went to the movies 10 times this year, but they only really just went one time. Yeah, so that is what we call a response bias. And the margin of error does not account for all of those bias. Okay? It will only account for the margin of error, only account for sampling variability. Okay, the gym teacher of a large high school wants to estimate the mean. Okay, we're not talking about proportion here, we're talking about the mean. The mean number of push-ups students at this school can do in 1 minute. He selects a random of 30 students from those who are there after school for sports practices, and he records how many push-ups each of the students in the sample can do in 1 minute. He determined that he is only 90% confident that the interval from 24.1 to 28.5 captures the mean number of push-ups that students at this school can do in 1 minute. Interpret this confidence level. We're not interpreting the confidence interval, but we are interpreting the confidence level. Okay? So, if the gym teacher takes, remember we have to put context, takes many samples and calculate a confidence interval. I know this is really long, yeah. Confidence interval for each. About 90% of them would capture the true mean. Okay, make sure true, not true proportion, but the true mean number of push-ups for students at this school. Okay, moving on. Explain what would happen to the length of the interval if the confidence level were increased to 99%. So our interval, let's write our interval. Our interval is from 24.1 to 28.5 currently, right? And right now, this is at 90% confidence level. If I increase it into a 99% confidence level, what would happen to the interval? We know that when we increase the confidence level, the interval gets wider, right? Because the margin of error would increase. Okay. How would a 90% confidence interval based on a sample of size 200 compare to the original 90% interval? So right now, we have from 24.1, 28.5, we're now talking about a sample with n equals 30 students. What happens if what happens to the interval if I do n equals 200 students? So technically, what happens to the interval if I increase the sample? And we know that when we increase the sample, the interval gets narrower because increasing sample size, hope this is making sense, decreases margin of error. All right. Describe one potential source of bias in this study that is not accounted for by the margin of error. And remember, there are three things that the margin of error will not account for. It's the non-response bias, under coverage, and response bias. So let's get an example. So a non-response wouldn't be, so response bias, because he's looking at them doing push-ups. So it's not like, okay, I did 5 push-ups even though, I did, maybe a response bias would be a student saying, I did 50 push-ups in 1 minute and then lied about it, right? But the gym teacher is actually recording the push-up of each student in 1 minute. So he's there, so they can't lie about it. So response bias wouldn't be something that is happening here. What about under coverage though? What is under coverage again? Let me change the color. Under coverage. What does that mean? So maybe students who are not after school athletes did not have a chance or the chance to be part of the sample, right? And you can think of something else, but for now, I'll go with the under coverage, because you know how when you do the interpretation, we said that capture the true mean number of push-up for students at this school. But if you really think about it, it's not everybody that's been in there, right? And it's not even a random sample. He just went in there and asked the kids, right? So this is supposed to be just this. That's why we are doing the under coverage, because some people or some students in the class or in that school didn't have the chance to be part of the sample. Okay, so this is an example of a potential source of bias that our margin of error will not account for. Okay, thank you everyone, and I hope this video will help you answer your homework about confidence level, and I will see you guys in the next video.